Hello, everyone. Let's take a look at the news first. Recently, the issue of defective concrete in Changsha, Hunan Province has attracted wide attention. On October 28, a letter of notification was posted on the wall of the International Huadu community in Changsha Qinsheng District, saying that the 12th to 27th floors of Building C10 were being reworked and reconstructed, with a construction period of about 4 months. Due to the concrete quality, more buildings using defective concrete have been exposed. On the evening of November 9, the official account of Changsha Housing Construction Group Company Limited issued a notice on the quality problems of concrete produced by Hunan Tuoyu Concrete Company Limited. According to statistics, a total of 59 projects in Changsha City are using concrete from the company. According to judicial authentication, the reasons why the compressive strength is lower than the design strength are mainly as follows. Among them, some coarse concrete aggregates have low micro-hardness. The hardness of coarse aggregate mentioned here is generally expressed by the strength of coarse aggregate in engineering. Coarse aggregate refers to stones. Coarse aggregate and sand are used as skeletons and filling in concrete, inhibit the shrinkage of cement, and greatly affect the strength of concrete. Today, let's learn about the strength of coarse aggregate, determination of crushing index. The strength of coarse aggregate can be expressed by the compressive strength and crushing index of country rock. What is the country rock? It refers to the rock before the crushed stone rolling. Generally, only crushed stone has country rock, so the compressive strength is suitable for crushed stone, while the crushing value is suitable for both pebbles and crushed stones. So both indexes can reflect the crushed stone strength. But what is the difference between these two indexes? Generally speaking, it is more convenient to measure the crushing value in engineering. The compressive strength will be measured only when there are special circumstances. It can be said that the crushing index is the simplified version, while the compressive strength is the standard version. Let's learn the crushing index first. The crushing index is the ability of an aggregate to resist crushing under successively increasing loads. So how to determine it? According to the test method of crushed stone and pebble for construction, GBT 14685-2011, air dry the 9.5 to 19.0 millimeters sample. Remove the elongated and flaky particles. Divide the 3 samples into 2 layers with a weight of 3,000 grams each. Load them into the steel cylinder of the crushing value instrument. Place them on the press machine. Uniformly load them to 200 kilonewtons at a loading speed of 1 kilonewton per second. Stabilize the pressure for 5 seconds, and then unload them. Determine the percentage of mass smaller than 2.36 millimeters in sample mass, and the percentage is called crushing index. The calculation formula is that sample mass, 2.36 millimeters screen residue, is divided by sample mass and multiplied by 100%. So, how to operate? Let's look at the calculation process. Pebble and crushed stone for construction, GB T14685-2011. 1. Instruments and equipment. Pressure testing machine, a universal pressure testing machine for this time. 1. Instrument and equipment. Crushing index tester, compression test mold. The diameter of pressure head, 150 millimeters. The inner diameter of the round die, 152 millimeters. Outer diameter of base plate, 182 millimeters. The thickness of round die, 10 millimeters. 1. Instrument and equipment. A balance with a capacity of 10 kilograms and a sensitivity of 1 gram. 1. Instrument and equipment. 4 square mesh sieves with an aperture of 2.36 millimeters, 9.50 millimeters, 16.0 millimeters, and 19.0 millimeters respectively. 1. Instrument and equipment. A backing rod with a diameter of 10 millimeters and length of 500 millimeters. 1. Instrument and equipment. A sieve shaker. 1. Instrument and equipment. A needle gauge and flake gauge. 1. Instrument and equipment. Auxiliary tools. 2. Environmental conditions. Laboratory temperature 20 plus or minus 5 degrees Celsius. 3. Preparation before the test. 1. Check the ambient temperature and humidity and fill in the record. 2. Check whether the equipment operates normally and fill in the records. 4. Sample preparation. The samples taken shall be divided by quartering to the amount required for the test. The samples shall be air-dried for later use. Screen out the particles larger than 19.0 millimeters and smaller than 9.50 millimeters. When the particles with a particle size between 9.50 and 19.0 millimeters are insufficient in the test, it is allowed to crush the particles with a particle size greater than 19.0 millimeters into particles with a particle size between 9.50 and 19.0 millimeters, and they are used for the crushing index test. After shaking the sieve, remove the set of sieves. Place it on the workbench and remove needle-shaped and flaky particles with the needle and flask gauges. Flaky and needle-shaped particles. Flaky and needle-shaped particles picked out. Sample 1, Sample 2, and Sample 3. Put 2 layers of samples into the round die. After the 2 layers are compacted, level the surface of the sample in the mold and cover the pressure head. Place the round die with the sample on the pressure machine and start the machine. Uniformly load 200 kilonewtons at a loading speed of 1 kilonewtons per second and stabilize the pressure for 5 seconds before unloading. Remove the pressure head and pour out the sample. Screen the crushed particles through a sieve with an aperture of 2.36 millimeters. Weigh the mass remaining on the sieve, accurate to 1 gram and represented by G2. 5. Test steps. Repeat the above test steps and complete the other 2 samples in turn. 6. Calculation results and expression. Crushing index, accurate to 0.1%. QE equals G1 minus G2 divided by G1 times 100, where QE, crushing index, percentage, G1, sample mass, gram, G2, mass of sample residue after crushing test, gram. How to calculate it? According to the formula, the crushing index is equal to the mass of particles less than 2.36 millimeters divided by the sample mass. In the first step, the mass of particles less than 2.36 millimeters is equal to the sample mass of 3,000 grams minus the mass of residue on the 2.36 millimeters sieve, or 2,340 grams, which is equal to 660 grams. In the second step, 660 is divided by the sample mass of 3,000 grams and multiplied by 100%, which is 22.0%. Please note that the crushing index is retained at 0.1%. Similarly, the crushing values of the other two samples can be calculated to be 22.2% and 21.8% respectively. In the third step, calculate the average value of three samples. 22.0% plus 22.2% plus 21.8% divided by 3 equals 22%. Note that 1% of the average value is retained as the crushing value of this sample. Here, please think about the relationship between crushing index and strength. The greater the crushing index is, the higher or lower the strength will be. According to the formula, a larger crushing index means more particles smaller than 2.36 millimeters, indicating that there are more crushed particles and lower crushed stone strength. How to judge? According to Table 6 of GB T14685-2011, Crushed Stone for Construction, the crushing value of Class 2 crushed stone shall be less than 20%. In this case, the crushing value is 22%, larger than 20%, and does not meet the requirements. Summary. In this lesson, we have learned the crushing index reflecting the strength of coarse aggregate. The crushing index is inversely related to the strength. The crushing index test can be summarized into 5 steps: particle screening, molding, pressing, sieving, and weighing. Please pay attention to the details to ensure that the test is done correctly. Regarding the progress of the Changsha Qinsheng International Huadu concrete case, in March 2021, the Intermediate People's Court of Changsha City, Hunan Province, ruled that the boss involved in the Changsha Qinsheng International Huadu case was sentenced to 9 years, and the laboratory director to 7 years. This lesson tells us that as a future municipal and traffic engineering technician in the new era, you must improve your professionalism and inspect raw materials in strict accordance with national standards in the future engineering practice. Ensure that the qualities meets national standards and contribute to the country's modernization. Please think about whether the aggregate cannot be used in engineering if the crushing index is unqualified. That's all for today's class. Thank you.